Solve the system of linear equation using matrix method. This looks like a standard equation, so we can directly go on to express in form of expressing in Ax is equal to B form. So we have this to be 1, 2, 1, minus 1, 1, 1, 1 minus 3 and 1, and this is x, y and z, and this is equal to 4, 0 and 2. Now checking the feasibility of finding the solution. So we're looking at a consistency, that is right. So basically determinant of A would be 1, 2, 1. Actually I could have just copied it. Now what do we have? So we can take up, I guess, expanding along. R3, right? So this would be plus minus plus. So we have 1 into, we have 3 and minus 1, then minus 1 into, then we have minus 3, minus 2, and we have 1 into 1 plus 2. Certainly not 0. So this is 5 and this is 3. So this is 10. So from this we can imply that the equations have solutions. Now, how do we figure out the solution? So for that we need to figure out the adjoint, or we can start off with the minor. So I would like to do this first. Where is it? Yeah, we have to figure out the inverse. For finding out the inverse, we need to figure out the adjoint, and well, we have found the determinant. To figure out the adjoint, we have to go back to this minor cofactor, then a matrix and transpose. So I'm going to figure out the minor first. Representation of minor of Aij. Okay, let's do this. So first I can do M11 here itself. So that would be 1 and 3. So this is 4. Then we have M12. So that would be 2 and 3, that is 5. Then we have M13, that would be 2 and 1, that is 1. M21, so that would be this and this eliminated, so minus 2. Then we have M, this would be 2, 2. So clearly 0. M23, this and this, so minus 2, right? So this, oh sorry, plus 2. M31, 31 is this, so plus 3 minus 1, 2. Then M32, M32 is over here, minus 3 minus 2 minus 5. And finally we have M33, so that would be 1 plus 2, that is 3. And then we can find the adjoint of A. So the trick is we have to write the minor first. Just write it. Don't think about the sign. So that would be 2 minus 5 and 3. Okay. Now think about the sign. We need to transpose this. So this is positive, negative, positive. This is negative, positive, negative, positive, negative and positive. And then finally we can transpose it for the above. So 4, 2, 2, minus 5, 0 and 5, 1, minus 2 and 3. Okay, so we're almost there in finding out our inverse. So A inverse is 1 by adjoint of A into our, sorry, not adjoint of A, that's what I was thinking, determinant of A into adjoint of A. So determinant of A is 10 and this we can copy. So there is nothing common, no. So we'll just have to keep that as it is. And so A inverse is 1 by 10th of this particular. Now, so we know A inverse. Can we figure out what else do we need to figure out? That's it, right? Yeah. So X, which is equal to A inverse of B. So we have A inverse, this entire expression. And then we have B. B will turn out to be 4, where is B? Yeah, 402. 4, 0 and 2. Okay, so we have 1/10, no space, we'll do it over there. So 1 by 10, and then we have the 4, 16, 0 and 4, all of this are added. Then we have minus 20 plus 10, then we have 4, 0 and 6, all are added. And finally we have on the left hand side, so we always had x, y and z that we can compare with. So we have, on comparing the matrices actually, so we have x to be 2. Again, remember we have 1 by 10, remember. Okay, then y to be minus 1 and z to be 1. So that's our answer.